This video is going to cover how to conduct a one-sample t-test along with an example. So the rationale for testing hypothesis about the mean of a normal population is the same as the rationale that we met earlier for testing hypotheses about a population proportion. So we're going to use this to conduct a one-sample t-test. So what we do is we draw a simple random sample of size n from a large population having unknown mean to test the hypothesis that the mean equals mu naught. That's kind of what we set the mean to be, and you'll see that better in the example. We're going to compute the one sample t test statistic like this. So I have t equals x bar minus mu naught over s over the square root of n. Okay, so in terms of variable t having the t sub n minus 1 distribution, the p-value for a test of h naught against, we've got our null hypothesis of mu being greater than mu naught. That'd be p of t is greater than t. We have our alternate hypothesis of mu being less than mu naught. That's a left-tailed t-test. So our t would be less than t. When we have a two-tailed test of mu less than or equal to mu naught, so we'd have 2 times the probability of t is greater than the absolute value of t. And these p-values are the exact if the population distribution is normal and are approximately correct for large n and other cases. So we should definitely go through an example. So we're going to follow the 4-step process for a significance test. First, we need to state our data. So one website considers it unsafe if a 100 milliliter sample of water contains more than 88 chloroform bacteria. Here are the fecal chloroform levels, coliform levels found by laboratories at 12 Ohio State Park swimming areas. So here are 12 pieces of data. Is this data good enough evidence on average that fecal levels in these swimming areas were unsafe? So for that, we're going to have to set up a t-test. Because our sample is less than 30, we can't use a normal distribution. That's one of the main reasons you're going to use a t-test. So let's switch to a better color. We asked the question in terms of the mean mu levels for all these areas. So our null hypothesis is the level is not unsafe. That would be that there's no difference. Our null hypothesis is that mu equals 88. And our alternate hypothesis is that the level is unsafe. So that would be that mu is less than 88. Sorry, mu is greater than 88, right? Greater than would make it unsafe. So what we're going to do is we are willing to regard these particular 12 samples from a large population as possible samples. So we've made a histogram that doesn't let us judge normality, but our data are somewhat skewed to the left, right? If the hump's on the right, it's left skewed. And our p-values may only be somewhat accurate, right? This isn't like the best data. So based on our sample, we calculated a sample mean of 113.75 and a sample standard deviation of 93.9. So we're going to calculate our t by taking our sample mean minus our population mean over the standard deviation of our sample divided by the square root of n. So I have 113.75 minus 88 over 93.9 over the square root of 12 is 0.95, okay? That's my t value for this data set, okay? So we found a p-value for t is 0.95. That's the area to the right of 0.95 in the t distribution with degrees of freedom n minus 1 equals 11. So we need to go to a t-table. We know that our degrees of freedom was 11. We need to look in here, right? And 0.95 falls right here, right? So between 70 and 65, right, our area in our one-tailed P is in between there. We really cannot reject the null hypothesis because this is such a high p-value, right? We want typically something like between 5, and 1. If I had calculated and got a critical T, of like 2.5, then I could accept at the zero point 0.5 significance level, but our value was way, way too low. So we're going to fail to reject our null hypothesis.